So we saw the definition of convergence of a sequence using the epsilon definition. And as you know, that can be kind of unwieldy. So just like we did for functions, we'd like to have some basic properties that will allow us to evaluate limits without going through proof by definition. So we've got these. So assuming you have two sequences, a sequence A that converges to some A, sequence of B's that converges to some B. So they're both convergent, first of all. Then the sum or difference is the sum or difference of their sums. Constant multiple times all the terms, that limit would just be the constant multiple times the sum. And the limit of a product is the product of the limits. And same thing with quotient, except for if the bottom is going to 0, then it's not going to be A over B because that doesn't exist. So, but as long as B is not 0, then it's just a ratio of the limits. So let's look at an example of how this allows us to evaluate limits quite easily. So for example, say we were taking the limit as n goes to infinity of 2n squared plus n minus 4 over 3n squared minus 6n. So what we could do is we can think of this as a whole bunch of different limits using this property. So remember, we can still use the algebra approach to get started. So remember, if we multiply top and bottom by 1 over the highest power there on the bottom. So this is just algebra. I haven't used the laws or properties of limits there yet. Just getting it into a better form. Okay. So now, combining all these limit properties together, I can say that this is equal to the limit as n goes to infinity of 2 plus the limit as n goes to infinity of 1 over n minus 4 times the limit as n goes to infinity of 1 over n squared over the limit as n goes to infinity of 3 minus 6 times the limit as n goes to infinity of 1 over n. And now this is what this limit is the limit 1 over n, 1 over n, 1 over n. So any rational expression could really be broken down to a bunch of limits of 1 over n via the properties. And so then this just becomes 2 plus 0 minus 4 times 0 squared over 3 minus 6 times 0, or 2/3. Now, we usually don't go through this detail every time. If you remember in Calc 1, we would kind of show you this when we first got these properties for functions at infinity, or for any limits really for functions. But this is why we can look at something like this and just go, okay, that's going to 2, 0, 0, 3, 0, so it's 2/3. So this is just showing us why we know that. We know it because of these properties of limits. I don't need to see you write out this detail every single time, but I wanted you to understand why is it that we can go straight from there to there and know that that limit's 2/3. It's really because of these properties. I do want to see you divide out, though, because at the beginning here you've got this thing goes to positive infinity, this thing goes to positive infinity. That's a indeterminate form, so we don't know that that goes to 2/3. But once you've divided by n squared there, now this becomes a determinate form because it's 2 plus 0, which is just 2, over 3 minus 0, which is 3. So I do want to see that first step. This is just showing you why these properties of limits are important for us, why it makes life a lot easier for us.